Hi guys. In this lecture, we're going to be looking at shifting binary points and shifting binary numbers. We're going to look at how to perform those operations, and particularly the difference between shifting the points and shifting the numbers and the effects they have on the binary numbers themselves. Okay, so we're going to start with shifting binary points. We established how to convert between decimal and binary. So let's say, for instance, we have a binary number 01101. This can be as long as we like. Okay, so if this is all that there is to the number, okay, 10101001101 base 2, if this is all there is to the number, we can safely assume that this is 0.0 still in base 2. Okay, it's the same way if you're working with decimal and you have 15. It's the same thing mathematically as saying this is 15.0. all right, so the same thing applies in binary. So if we were given this number, it's also important to know that this is a binary point, not a decimal point as you may be used to. All right. So if we're given this number and we're asked to shift this number, okay, so let's say shifts the binary point. So BP is going to stand for binary point. 3 places left. 3 places left. So how this will work is that shifting binary points, the idea is to maintain the number. So it's like you're shifting the decimal point and multiplying by an exponent to keep the number the same. So if we were to shift these 3 places to the left, then this will come 1, 2, 3, and land right in between these two ones. So that's what we're solving here. So let's go. Shifting the binary point 3 places to the left is going to be 1 0. Okay, that's not it. 1 0 1 0 1 0 0 1. So now our binary point is in between these two guys. So we can put the binary point here. Point 1 0 1, and you can add the trailing 0. So any 0 after the final significant 1 doesn't have an effect on the number. Okay, so 0.101, I can call this base 2. But that's not all there is to it, because remember, we want to maintain the number. So you take note of how many times we shifted it. We shifted this number 3 places to the left. So that means we're going to multiply by 2 raised to the power 3, all in base 2, to keep the number the same. Okay, so the idea is to shift the number 3 places to the left. This number is less than this by exactly 2 raised to the power 3. So if we were to look at the decimal equivalent, so let's say we had 2,497, okay, 0.0. If someone has asked us to shift this number 3 places, the decimal point 3 places to the left, we're going to end up with 2.497. But how do we make sure this number is the same as this? We multiply by the base of the number, so that's 10 since this is decimal, times 3. Okay, so this is now engineering standard form. So that's going to be 2.497 times 10 raised to the power 3, which is going to give us 123, which is going to be the same as 2,497, the same number we started with. So the exact same thing is what's going on in decimal. When you're shifting the binary point, you want to maintain the number. So you move the binary point and you multiply by the exponent. Okay, so this is in base 2. So moving the binary point has no effect on the number. So if we were to shift the binary point, so let's say we have to shift the binary point. Okay, so let's say 4 places left. So 4 places left. So let's see if we can do that. Remember we had, okay, so let's erase this. Let's keep this out of the way. So remember we had 10101, 001101, and our binary point is somewhere over here, 0.0. So if we were to shift these 4 places to the left, so count with me. This is 1 movement, then 2, then 3, then 4. So our binary point is meant to end up here with 4 zeros separating the last one. Okay, so let's do that. So that's going to be 1 0 1 0 1 double zeros, double 1 0 1. So remember, this is where the regular number stopped, but we're shifting. Okay, so this 4 places right, pardon me. Okay, so shifting the 4 places right. So this is where the regular number stopped, the first number we had stopped, but we're shifting our binary point 4 places right, so we can add 4 more zeros. So that's going to be 1 2 3 4. If we were to fill the zeros in here, it's still going to be 0, 1, 2, 3, and 4 zeros. So if we want the number to stay the same, we know that we're increasing the number now. Because if you check, this is longer than this, which means it's bigger. Okay? So to keep this the same, we're going to multiply by a number that's going to reduce it. So that's times 2 raised power negative 4. So that this reduces the number by 2 raised power the number of times you shifted the point to the right. It usually helps to look at the decimal equivalent. So let's say we had a number 34985. So this is 0.0 regularly. And someone asked us to shift this binary point, okay, let's say 2 places right. Okay, so shifting this 2 places right. So plus 2 places, so let's call this right. So we're going to end up with 34985. This is our regular number. Then 2 zeros. But then to keep this the same as what we had before, we'll multiply by 10 to the negative 2. Okay, which is the same as dividing by 10 squared, which is 100. Okay, so it's the exact same concept when dealing with decimal. Shifting the binary point has no effect on the overall number, but it does change the integer part, the parts that you're going to multiply by the base and whatever index you have. Okay, so now let's move over to shifting binary numbers. So this is not the same as shifting binary point. Okay, so let's take for instance 1 0 0 1 0 1 0 1 1 1 0 0 1 0 1 0 1. So this is in base 2. Remember what we've done before is shifting the binary point. Now we want to shift the binary number itself. So if we're to shift the number, 3 places left. Okay, so shift the number 3 places left. So think about it as it is sort of doing the same thing as you're doing when you're shifting the binary point, but instead of moving the point, you're moving the entire number. So it's as though you're carrying this whole bunch and skipping it 1, 2, 3 while keeping the binary point constant. So that means zeros are naturally going to fill in whatever place you have here. Okay, so let's see how that works. If we're to shift these 3 places left, that means we're going to end up with 1 1 0 0 1 0 1 0 1. So this is the number we had at the beginning. So since we're shifting 3 places left, it's like we keep the binary points constant. Okay, so let's say if each number takes a cell like this, we're just going to move each one 3 places left and keep everything else the way it is and fill in the rest with zeros. All right, so that means we're definitely going to add 3 zeros after our final digits and before the binary point. So that's 1 2 3 0 base 2. Okay, so we can see that this is naturally bigger than this. So shifting the number itself 3 places to the left actually increases the size of the number. This may look the same as shifting the point 3 places right, but if we did that, we would have to multiply by 2 to the negative 3. Okay, but we're not doing that here. We're shifting the number, so that means this is bigger than this. And then by how much? So this is bigger than this by exactly, let's not use, so this is bigger than this by exactly 2 raised power 3, which is 8. So if we were to convert this to decimal, this is going to give you 405. Okay, and this is 3240. So if we were to compare the two numbers, if we were to do 3240 over 405, you're going to end up with 8, which is exactly what we predict. So shifting the number 3 places left actually increases the number, okay, by a factor determined by how many places you're shifting it. So let's do the converse of that. Okay, so if we were to shift the number 3 places right, so let's go. What will we do? So remember, we're saying we're keeping the binary point constant. So let's say we're assuming each number takes up a unit, so something like this, right? So usually everyone after the binary point would have been 0, since if we're doing, okay, so let's say we have 1 1 0 0 1 1. But if we're shifting the number to the right, remember we're keeping the binary point constant. That means this guy skips 3 places, right? So that's going to be 1, 2, 3. That means this changes to a 1. This guy skips 3 places, right? 1. Okay, so let's do that. 1, 2, 3. Okay, so that means this changes to a 1. And this guy skips 3 places, right, too. So that's 1, 2, 3. So this stays, it's just going to stay at 0. So that means everything else shifts 3 places to the right. And then you're going to end up with 110.011 as you started. So let's do that. If you're keeping the binary points constant, that means the last 3 numbers are going to be after the binary points. It's as simple as that. So that's going to be 1100.101. So 110010.101 in base 2. So if you want to check, this is going to give you 50.625 in base 10. All right. And for those that are curious, 405 divided by 50.625 is exactly 8. So shifting the binary points 3 places, shifting the binary number, 3 places right, reduces the number by a factor 2 to the 3. Shifting the number 3 places left increases the number by a factor 2 to the 3. So that's all there is to shifting binary points and numbers. If you start to code in C and you're dealing with memory allocation and you want to perform operations, it's actually called bit mask. So if if this was a binary number, so let's say V is a variable number, you will signify it with something like 3 arrows, arrows like this to tell you, okay, move this, perform this bit mask operation on this, move this 3 places to the right, so I can do an operation on the last number here. So that's sort of how it's used in coding and applications. But that's all there is to shifting binary points and numbers. Remember, when we're shifting the binary points, we're trying to maintain the same number. So we'll have our shifted number multiplied by 2 to a certain exponent to preserve that number. If we're shifting the number itself, the number is actually going to increase or decrease by a factor of 2 raised power whatever number we're shifting it in whichever direction there is. So thanks for watching, and I'll see you in the next video.